So what I'd like to do over the next 40 minutes is talk about a recovery program in another island in New Zealand for an endemic bird, the Hihi. And we've moved from the Canary Islands, we've gone to Hawaii, we've been down to Mauritius, now we're going to another archipelago, and it's the same stories, problems we're being confronted with every time, and this is going to continue tomorrow as we move to some other islands. I've summarised this as this infamous evil quartet of the loss of habitat, habitat fragmentation, the introduction of alien species, non-native species, particularly mammalian predators in situations like Mauritius and New Zealand. This nasty rat here eating a fantail, over-exploitation and those cascading effects. And I'm starting on a bit of a sad note, but I don't really want to stick on the sad note. But the reality is places like New Zealand have actually lost half of their vertebrate fauna over the last 750 years. So this equates to about the time that people have been associated with New Zealand. We've lost half of our species. But it was quite telling at the end of Chris Dow's presentation. There was a comment about a gaping wound bleeding out that we're trying to cover with a Band-Aid. I'm much more of an optimist. I think we've heard some fantastic stories of hope and recovery in the Canary Islands. We've heard some fantastic stories of recovery in Hawaii, Mauritius, and now New Zealand. And again, this will continue tomorrow. The extent of the threats are known. This is a good place to be in. We know the problems. We can therefore identify solutions, and we can get recovery. It is entirely possible to bring these species back, and we are, and we're doing it increasingly efficiently. So I think we should be a room of hope rather than a room of sadness, okay? So, in New Zealand, probably like most of these other island archipelagos, we have had some solutions, and our solutions were offshore islands. So the Department of Conservation, the New Zealand government, looks after at least 220 islands, which are bigger than 5 hectares, and hundreds of smaller ones. This is one example where I spend a lot of my time. It is Tiritiri Matangi Island in the north of the country. 30 years ago, that was all green paddock covered with sheep. And now you can see it is 60-70% forest, regenerating forest, planted by volunteers, much like the stories I heard this morning. Species were lucky if they were on these islands because many times these islands missed being invaded by non-native predator species. We have also used these islands to maroon some of our threatened species, so taking them outside of their native range and putting them somewhere safe. We've taken this to the next level in New Zealand, and we've started moving back onto the mainland. And so we have created an increasing number of mainland islands. Often these islands are managed by building a very expensive, very fancy fence. That fence stops everything bigger than a mouse. We then clean everything inside it, so we remove all the non-native predator mammal species, browsing mammal species, and then we can put our native species back. This example in the photograph is an area of over 3,000 hectares, and the fence is 47 kilometres long over very steep country. And we've removed 2 rat species, mustelids, rabbits, hares, deer, pigs, you name it, it's all out. Cats as well. So in areas where you get lots of cat reinvasion, build a fence and then clean them out. The inset picture just shows the number of these mainland restoration projects which are occurring across New Zealand. Many of these projects are run by community groups, not by the New Zealand government. So where does the Hihi fit in? So Hihi is my favourite bird on the planet. I've spent decades of my life looking after them, looking at them, and trying to help them, moving them around. So it's an endemic passerine from New Zealand. In fact, it's the only species in an endemic bird family, so it's highly unique. They're very small, so a male is about 30 to 40 grams, a female is a little bit lighter. They're quite generalist in their diet. They take a lot of nectar, they eat a lot of fruit, and they eat a lot of insects. They are somewhat challenging for a New Zealand species. So we can clean islands of non-native predators. We can build fences and we can clean mainland islands or mainland areas of these predators. Many of New Zealand's species then quickly recover. If we put these birds, reptiles back in, the solution has been made. Hihi is a bit more challenging and we haven't figured it out yet. So they appear to be highly sensitive to the disturbance in the forest environment. And it might be that currently New Zealand doesn't have the pristine forest environment that the birds need, except for their one remnant home. So Hihi were once found throughout the northern half of New Zealand. However, by about 1890, they had become restricted to a single offshore island, Little Barrier Island, which is in the north of the country. And the population has existed there, only there, since the 1890s, until we started working on them, trying to actively recover the species, beginning in the early 1980s. Actually, that island there is about 3,000 hectares in size. It had cats, which we successfully eradicated, and it had one rat species, which we also successfully eradicated. The cats went first, which caused a problem because the rats exploded, and with that mesopredator release caused a lot of problems for some of the other birds that were living in that place. Things to be wary of when you're trying to take out predator species. Anyway, since the 1980s, we've worked to try and recover Hihi, and the main way we do that is to translocate birds initially from that remnant population on Hauturu or Little Barrier, which is way up in the north, to found new populations through reintroduction. And this map is current as of last year, and it shows that we've managed to establish or start establishing 6 additional reintroduced populations of Hihi. Some of them on offshore islands, some of them on mainland islands. Each of those populations is still small. That's adult population size, breeding adults. And all of those populations require intensive management support. So the support that we provide these reintroduced populations is a whole gamut of things. We have to keep control of the non-native mammalian predators. We provide supplementary feeding to all of the populations. We have to provide them with nesting sites in some of those populations, especially if the forest is young and regenerating. They're a cavity nesting species, so they need large trees with natural cavities to be able to breed. Failing that, we can provide them a wooden box and they do just fine. We have to manage parasites in some of those populations, and the parasites of particular concern are nest mites, and they infest nests and nestlings, and they can cause nestling mortality if they are left unchecked. Again, that's only some of the sites, depending on the climate. And of course, once we've embarked on these recovery strategies, programs, our commitment is long-term. The project does not end when you open the door of an aviary and let the birds go. We need to monitor to ensure that our objectives are being met, and we need to monitor and refine our management actions to make sure that we're being efficient and that what we're doing is actually achieving what we intended it to achieve. So the Hihi in New Zealand is managed, or the management of the species is coordinated by a recovery group, a species-focused recovery group, which is coordinated by the New Zealand government, so New Zealand Department of Conservation. However, it has representatives from the government, but also the community conservation groups which are involved, and a bunch of researchers, including myself, who have been involved for many years trying to help inform the recovery of the species and also learn more about it. So importantly, our management of Hihi is driven by clearly specified objectives, and these are the objectives that all of our work is trying to achieve. And we've got 4 fundamentally important objectives for Hihi conservation. We want to increase the number of Hihi we have on the planet. We want to increase the degree to which the places where we have Hihi are natural. So yes, we provide boxes, yes, we control parasites, and yes, we provide food. We have to. But actually, we would prefer to see Hihi living naturally in New Zealand environment without the management support. So we are trying to get to that place. We, of course, want to do this without spending lots of money. And importantly, we want to increase the appreciation that New Zealanders have of this species. So we think it's fundamentally important that New Zealanders know about their native species and care about them. And so we have some measures about what we mean by those objectives and some units that we can actually assess our possible management actions to make sure that we're choosing the best one. Okay, and over the decades we have learnt some good things. We're still learning a lot of things. And we have developed some best management guides about how to support Hihi recovery. And we published this last year, and you can actually access and download it shortly from our website. And it goes into how we go about doing our management and why we do it the way that we do. Some of the things that we cover include advocacy, the building and maintenance of nest boxes, how we should feed the birds, how we should catch birds, what health screening we should do, how best to monitor the populations, so monitor breeding, monitor survival, with some good examples of how we use that data to inform our management, and also how best to translocate birds. So with Hihi, we don't use the captive breeding phase, we do wild-to-wild translocation. Right, so as some examples of where we've worked out or continue to play with management protocols, there's some nice examples of things that we've learnt or been confronted with over the years. For example, how we deal with parasites or the risks of disease transmission through a translocation. This nasty photo in the bottom is of Aspergillus causing mortality in a Hihi. It's one of the fungal pathogens that Hihi suffer from in the wild. And we've had it's taken many years to figure out exactly what disease screening we should be doing, why we're doing that disease screening, and what it means for the risks associated with translocating birds from one place to another. So I can make these papers available if anybody would like to read more detail about that. Another area where we have been doing interesting work, I believe, is really testing the effectiveness of different management solutions. So rather than believing that our management is doing what we think it should be doing, we try and always test to ensure that it is, or to refine it if it's not. And this is just one example of work we've looked at dealing with management of those nest mites or nestling mites. The way that we manage nest mites is to check those nests very frequently, almost every second day, that there are nestlings in a nest, and there are nestlings in a nest for 30 days in a hihi. If we detect nest mites are present, we treat those nestlings with a miticide, frontline, which is what we all treat our cats and dogs with. Works very well for mites as well. If the infestation is very heavy, we actually change the box and put a new nest, fake nest, on the tree and put the chicks in there after treatment with the frontline. And we can see on the graph here, boys are bigger than girls, so that the dark black line is the boys, the lighter lines are the girls. If we treat the mites, the nestlings grow to be a bigger size by the time they fledge, and they're 1.4 times more likely to fledge than if we let the parasites stay in the nests. So we know that we're having a positive effect with our mite treatment. As another example, I added this in today at lunchtime because I thought the conversation was circling around some of these ideas or concerns this morning around the blue chaffinch. There is a risk where we're in a changing climate, the globe is rapidly changing, temperatures are changing, and there is a risk that current suitable habitat may no longer be suitable into the future. And what can we do? And this is a similar concern that we have had with hihi management in New Zealand. And we had a PhD student look at this a few years ago. And she used an interesting approach where she took our long-term monitoring data and build a population projection model, or a population model at least, which related hihi demographics to fluctuations in temperature and rainfall. And then she looked and found some worrying relationships between increasing temperature and decreasing demographic vital rates. She then looked across New Zealand at the available places where there was habitat, so forest, that was being protected from predators, because this was something that needed to be sorted first, and then she could predict where the suitable habitat would be at certain time points into the future, depending on which climate model you believed or climate scenario that you believed. And perhaps not surprisingly, New Zealand being in the southern hemisphere, suitable habitat is shifting south. So in this case, actually, suitable habitat is shifting into the South Island of New Zealand, which is outside of historic or indigenous range of the species. So we have suggested in this article, and we continue to talk about it through the recovery group, that maybe we should be thinking about a conservation introduction to best recover hihi. So let's move them somewhere where they have never been before to anticipate the future changes that are coming. I just put that out there because I think it could be something interesting to also consider with blue chaffinch. Right, I'm going to shift focus a little bit now because this is a theme that I think is critically important and hopefully obvious but also very useful for everybody to think about for challenges of blue chaffinch or any other species we're trying to recover. And it's also a theme that Stefano is going to pick up and develop much more fully in his presentation shortly. So I think that reintroductions, in fact all types of population management or population recovery, should reflect deliberative decisions, so careful thinking. So what I mean by that is that population recovery often requires us to make a series of very difficult decisions. The answers are not easy, and they're not easy for lots of reasons. To answer these questions, what we have to do is first have a very good understanding of what our values are. So what's important? What are we trying to achieve? And we also need an in-depth understanding of the consequences of the choices we make. So what is likely to happen if we choose a given alternative, if we decide that we're going to keep captive breeding blue chaffinch and reintroduce them to Cumbria, what is the future going to look like? Versus if we stop doing captive breeding and do wild-to-wild translocation of blue chaffinch to Cumbria. What do those two alternative futures look like against what we care about? Then I can actually answer the question of which is the best action to take. So this is this idea of decision support and how we make the best use of all the science that we have available to us. So to embed our science in management, what we need to do is identify our objectives. What is important to us? We need to identify the possible actions that we could take. So what can we do to achieve those objectives? Predict how each of those things performs. Remember, when we're making decisions, it's a forward-looking process. We have to look into the future and see alternative futures to be able to make a rational choice about which is the best road to take. Then we can solve any trade-offs that need to be solved and make an informed management choice. So how have we, I'm now putting an academic hat on, how have we as a discipline in reintroduction biology been doing in actually following that type of simple recipe for success? And this is a review that another PhD student of Stefano and I has published recently, showing not that great actually. If we review all of the literature in reintroduction biology since the term was coined in the early 1990s, right up until fairly recently, you can see that about 20% of studies, and that proportion has not changed, actually explicitly compare more than one action and based on the results say which one is better at getting the result we want. Most often what we do is one thing. We see what the result is and then we decide post hoc if it gave us the answer we wanted, we recommend everybody should do it, and if it gave us the answer we didn't want, we recommend nobody should do it. Not very strong. So I think we could all do better to improve the scientific support that backs up the field of reintroduction biology. And so for the next little bit of the presentation, I want to give some examples of where we've tried to follow that idea in our providing decision support for Hihi recovery in New Zealand. So the first example that I'd like to share is one that focuses around a problem that managers had around providing supplementary food to a reintroduced population of Hihi in New Zealand. So this is a reintroduced population on Kapiti Island. You can see the lovely hill that Hihi live on top of in the second photo. The supplementary food we provide Hihi is sugar water. And the rangers, there's Nick in the kitchen down the bottom, who mixes up the sugar water, puts it on his back, and then walks up the hill every day to put it into the feeding stations that you see on the last picture. That was fine when we first reintroduced the birds, and there were 40 birds on the island. But the birds did very well. They loved this food, and the population grew very quickly. It grew so much that Nick couldn't carry enough sugar up the hill to feed the birds. So there was a problem. What was the government going to do? And so we've captured the decision problem here in what we would call a consequence table that summarises the decision frame that we're looking at. We have our management objectives in the first column. And the way we define this problem, what we cared about, or the managers in this case cared about, was increasing the number of Hihi, reducing the cost of management, reducing the probability that that population would go extinct, and reducing the probability that we would have a global extinction event. A team of experts got together and thought of the different things we could do. What options did we have to solve this problem? We could redistribute the feeders somewhere easier to get to put the food out, and keep providing as much food as the birds needed. We could provide the same amount of food that we reached at our capacity. We could just work harder, get more money, employ more staff. We could do nothing, just keep doing status quo. We could change to some complicated dynamic feeding, only provide food when the birds needed it. Or we could take Hihi off the island, because we knew without the food, the population was not viable. So we have 6 different actions that we had to choose between based on 4 different things we cared about. And this is a very quick and dirty analysis. We did it over a period of 1 afternoon with some experts in a room. So the numbers that are inside the matrix are either our estimated future or based on some monitoring data, right? So let me go one example. Let's go to the best one. If we increase the amount of food to existing feeders, we would be rewarded with 180 estimated adult Hihi in the population. But on this relative score of cost, it's the most expensive thing we could do. The probability the population would go extinct is 0, and global extinction is also 0. And so you get the idea of how the matrix is filled. So what is the best thing to do? Well, I don't know, maybe you already can see the answer. The first thing we can do is quickly try and simplify some unhelpful components in this complicated puzzle. The first is we can remove irrelevant objectives. Clearly, global extinction is not irrelevant, but for this decision, it is. It does not vary across the actions, so it doesn't help us choose the best one. So let's get rid of it. The other thing we can do is look for and remove any dominated alternatives. This just means that at least one of the other actions performs the same or better across those objectives than those 2 columns in the red. So again, dynamic feeding gives us the same number of Hihi, it's cheaper, and there's no difference in probability of extinction. This action will always beat this action, so we can get rid of that one. Are we following? Is that good? Easy. So our problem has shrunk. Is it easier now to figure out what the best thing to do is? Maybe. There's one other thing we probably need, and we should recognise. We've stated 3 things we care about. It doesn't mean that we care about them equally. So we need to ask the decision maker how much they care about each of those things. So we did this. In fact, we did it for the whole recovery team that was involved with this decision. And we worked out how much they cared about each of the objectives. So they cared about number of Hihi about twice as much as they cared about the population on Kapiti going extinct. Once we have that, we can solve it. And we can solve it using a technique from decision sciences, the simple multi-attribute ranking technique. And just quickly, what that does is it takes our raw estimates of what the future looks like, and from that, we figure out how much we care about each of those objectives, right? We then normalize those raw values, so they're all bound between a worst outcome, which scores 0, and a best outcome, which scores 1. We do that across each of the objectives. We then multiply those scores by how much we care about each objective to get our weighted normalized score, and we can simply add them up, with the idea being that for a given set of objective values, the rational choice is to take the number that gives you the biggest reward, the utility of this decision. I have to note here that we shouldn't just be driven by numbers. The process is what's important. It helps give insight to the problem and the challenge that we're trying to solve. The numbers can sometimes help, ideally the numbers allow others to engage and understand the evidence that we've put on the table to help inform the choice. In this case, actually, the managers chose the second top option because it was much easier to figure out how they would implement it. Right, and I'm going to do one more example, this one a bit more quickly. So this is another decision support example that we provided, and it's done by an MSc student of mine and Doug Armstrong's at Massey University in New Zealand. And so Yulia was involved with a more recent reintroduction of Hihi to a different site, to Bushy Park, a mainland island. And what happened there was that we released 40-odd birds, and very quickly we lost a large number of them. So within 6 months of the release, we had gone from 20 females down to 4 females as our founding population size before the breeding season. So in this case, the decision was, and the managers of Bushy Park Reserve suggested, we think we need a reinforcement. We want a follow-up translocation of more female hihi to bolster our population. And so we frame this as a decision problem. And so here, I'm representing it in a very different way. Our objectives are, we care about the source population. So if we're harvesting now from another reintroduced site, the only site that we source hihi from for translocation, Tiritiri-Matangi Island in the north, that beautiful island I showed at the start of the presentation. So we are very concerned about not impacting the source from harvesting birds. We obviously care about the destination. We do not want the destination to fail. And something that's not shown here, we also care about cost. There's a cost associated with doing a translocation, monetary cost. And so we used our population monitoring data of survival and fecundity to predict the future under 3 different management alternatives. Actually, there was a fourth. The fourth was we give up and we remove birds from Bushy Park and put them somewhere else. But immediately that was taken off the table because the managers at Bushy Park did not want to go there. So we had 3 options. Do no follow-up translocation, which is the solid black line. Take 15 females in March 2015, which is the light grey, or wait 1 more year and then take 15 females in March 2016, which is the dark dashed line. So our decision was made in late 2014, and our predictions of outcome for the source population was the breeding season following the last possible harvest, right? So those are the dates. So we projected how many breeding females we would have in the source population in September 2016 if we did no translocation, translocated in 2015 or in 2016. And these are probability distributions. So we're taking parametric uncertainty on the population demography, the population model that we have built based on 20 years of data for the population on Tiri. So we can see, obviously, if you don't harvest, you have the most birds that will be there. The alternative harvest, depending on when it happens, will slightly reduce the population of breeding females on the island. The destination site is much the same, except the amount of information we have is much less. So the population was founded in 2013. So we've only got 1 or 2 years of monitoring data to make our projections. The projections are over 10 years, and you can see the confidence intervals are massive. And again, there are the 3 different alternatives if you do the follow-up or not. Just like in the last example, we asked the managers, in this case it was 2 people from the site at Bushy Park, 2 people from the source on Tiritiri-Matangi, 2 government staff, and that might be it, how much they cared about each of those different objectives. And incorporating the uncertainty in our parameters, weighted by how much they cared about the objectives, we summarised that weighted normalised score that you saw in the last example into this new distribution here. And basically what it told us was that a follow-up translocation was going to have very little benefit to this population, and people could, given their current weight on objectives, the most rational choice was not to do a follow-up. So in fact, we didn't do a follow-up. So now I'm just going to quickly conclude with 5 minutes, it's perfect. So what should we do? This is me wrapping up and then handing on to Stefano, who can explain all this stuff in Spanish a lot better than I can. I think we need to change our focus from alternatives, how we're going to solve problems, to objectives, why. So why focus thinking rather than how. We should translate these problems into very clear decisions so that we can actually solve them. So in this way, science informs our decisions and we stop thinking that science makes our decisions. So if I wind it back into Hihi again, Hihi recovery success, or why I think it's successful, it's a highly collaborative project with government, community, research, all working together on clearly articulated objectives, which cover all of the objectives that those different groups have. We try our best to embed our science within management decision making, so it's helpful. It requires a long-term commitment and has to be strategically designed. So species recovery is not a short-term thing. We're often in it for the long game. So Hihi recovery has been going since the 1980s, and it's not showing any signs of stopping soon for challenging species like this. And our research, or management, is clearly objectives-driven. So you can find out lots more about this project on our website, and you can download lots of other information, helpful stuff, if you are interested. And I'm going to finish now with a little plug. So Stefano, myself, and a few others, including Doug Armstrong, Phil Seddon, Axel Morenschlager, who's the chair of the Conservation Translocation Specialist Group of the IUCN, we have developed a training course in how to best implement the reintroduction guidelines. We've run 3 iterations of that course. Christelle's been in it. Not sure if anybody else here has. So you can ask Christelle, she'll say nice things. We are running the course again this year. The course will be run in Costa Rica. The website is now live, so you can check it out. It's a very good deal in a very beautiful place, and you can come and learn some of the things that I've been talking about and that Stefano will shortly be talking about. And thank you for listening.